Hi guys, my name is Dipulani and today we'll be talking about medical data anonymization using data platform. There are four other member in my team: Shaurya Maheshwari, Siddhant Tiwari, LAKSH Gupta, and Mihir Srivastava. Mihir Srivastava will talk about related works, gaps in literature survey, literature review. Shaurya Maheshwari will talk about problem statement and objectives. Siddhant Tiwari will talk about database model and design and implementation. LAKSH Gupta will talk about result analysis and responses. And now we go to the introduction section. Medical, billing and clinical record these days typically have hundreds of fields on every patient. We tend to see the advantage of sharing such data with second reviews such as researchers, economists, statisticians, computer science, and many more. The goal of this work is to supply tools for extracting required data from medical records and at the same time maintaining a commitment to the patient confidentiality. Data flow algorithm is an algorithm for use to provide anonymity to data in clinical and medical departments. It's achieved by generalization, substitution, insertion, and removal of information without losing the utility of data. This algorithm has been accused for trying to achieve anonymization by overgeneralization. The greatest number of distinct values are chosen and are generalized first. Medical data set pose a high security threat and require utmost level of disclosure control methods. Data flow is important before of the data. Adequate number of measures are taken to dispose loopholes that may lead to the record linkage. And these are the objective that we are trying. Th- these are the objectives that we are trying to achieve. Adaptive anonymization level, unbiased linking likelihood, big of and log and time complexity, scramble and multiple records, anonymized data. And now my friend Mir will talk about related works. Thank you.
Okay, so I'm here and we'll be talking about the related work. So coming to the paper written by Clayton P, which tells us about the protecting electronic health information. Basically, this article focuses on characteristics of SA data type like microdata and tabular data, and development of disclosure policy of aimed at serving and the confidentiality of disclosure question are explored. So the description of a person and other entities that are data subject, the ability of user to associate known data subject with information about them, the sources of data, expectation as to the contact of data subject, and the terms and conditions under which microdata and tabular data are released to user outside SSA. The factor controlling the decision whether or not to release anonymized data is discussed in this article. Coming up, the paper written by Cooper G, which tells us about the evaluation of ML, or machine learning methods for predicting pneumonia mortality and artificial intelligence in medicine. So this speaks about the statistical agencies that provide microdata for public use strive to keep the risk of disclosure of confidential information negligible. Assessing the magnitude of the risk of disclosure is not easy. However, whether a data user or intruder attempts to obtain confidential information from public use depends on the perceived cost of identifying a record, the perceived probability of success, and the information expected to be gained. In this article, a decision theoretic framework for risk assessment that includes the intruder's information and objective and strategy for compromising the database and information gained by the intruder is developed. Coming up next, the paper written by Duncan G. and Mukherjee. This was discussed in earlier reviews as well. So this speaks about microdata disclosure limitations, statistical databases, query size, and random sample query control. So this paper is basically speaking about the computational power for producing sufficiently anonymous database as one that makes individuals and entity-specific data available, such that the ability to identify individuals and other entities contained in the release data is controlled. While techniques for limiting and discovering interface that can be drawn from release data can be adapted from work in statistical database and from work in multiple databases. In this paper, we also provide framework for reasoning about disclosure, control, and ability to infer the identities of entities contained within data. This paper, there are formal definition and present null men, K-map, and wrong map as model of protection. Finally, we come up to a paper called subjected as MuArgus. Actually, basically, MuArgus is a software application developed to create anonymized microdata files. The CSC project has taken an older version of MuArgus and improved the MuArgus approaches to get the CSC project version 4.0. Individual identity risk estimation was one of the core issues that the EU sanctioned project CSC targeted. On this topic, IST80 developed on previous research done by Frank County to improve individual identity disclosure risk measure. These allow the identification of unsafe data to be protected by disclosure control techniques. The software MuArgus contains a new routine that has been implemented by CBSN in cooperation of IST80 for computing the Franconi or individual risk of disclosure. That's it for me. Now my teammate Shaurya will give you the rest of the presentation.
Hello, I am Shaurya and I will be discussing summary of gaps in literature survey. There are several security data flaws in current websites, like there are several methods to identify data like change of sample data to outsource data like data through social media and social profile. So we have to secure our data with anonymization technique and use more security, but at not cost of utility. So there are algorithms that can provide such a type of algorithm. And there are algorithms like Datafly, other algorithms that can provide high level of security, but at not cost of utility. Problem statement. Medical dataset constitutes to one of the most sensitive data. Thus, operations and transport of data with such security issues pose a threat to loss and fidelity issues, thus defining an algorithm that takes care of the threats and acknowledges the dataset post-anonymization methods needed to be developed. Datafly algorithm serves the purpose. Objectives. Through Datafly algorithm, we anonymize medical datasets by a series of steps. We perform operations like substitution, insertion, and other anonymization methods to mask the data and make it market ready for use by data analysts, researchers, business operations employees, etc. The database administrator governs the level of anonymity in the dataset. The anonymizer takes care of the underlying operations and release an appropriate version, maintaining an adequate privacy versus utility trade-off. Through Datafly, we also ensure a number of steps to prevent record linkage and data identification attacks.
So hi, I'm Siddhant. I was responsible for the coding and dataset job for the project actually. I used an MIC dataset which actually logs about 90 patients, their clinical records, the diseases they have been suffering, and it also had explicit identifiers like the name and the place they belong to. So this is the dataset I took. Now this is the basic design model which my team actually prepared. What we do is we'll actually calculate a bin size variable which will be defined as R2 minus R1 into A plus R1. This is an abstract value which we calculate, which is actually used afterwards. Now there's an option here which enlists that A, R1 or R2's value is decided by data anonymizer and N is the number of entries. Depending upon the number of entries, we actually define these values and then subsequently calculate B. Now there's one more thing. Now sometimes R1 and R2 is not directly provided by the user. So what we can do is we can actually calculate R2 on the basis of our R1. We know the fact that R1 is basically proportional to the number of entries, so we can actually constitute a res variable, which is basically 1 by 100 or 1 by 10 of the nth value. And after that, we can actually calculate the bin size per field. We've previously calculated the total bin size, and now we can calculate bin size per field, which is actually defined by B plus R2 minus R1 into the PF, which is actually a parameter that holds the likelihood of the recipient to participate plus R1. Now, keeping in mind the fact that the variable R2 is always greater than R1. We also have a number of replacement algorithms or recoding algorithms, which actually takes a reiteration number and returns a Boolean value denoting whether the highest level replacement has been performed or not. And this way, after doing this, after completing this algorithm, they come to an end. Yeah, this is more or less the code we have generated. We actually define test cases where if like this is an example of configuring age. We actually try to anonymize the age by replacing the continuous value with a categorical value. And this is a little code segment how we define the age part, and then we actually define the zip part. Zip actually we actually anonymized it by using the first 3 digits of the digit and then actually using 2 stars which should anonymize. Also, we anonymized the country by just writing Italy instead of the city birth. This way we were able to anonymize 3 fields. This is the unanonymized data set. Previously we had explicit identifiers like city birth, zip, and the diseases, and now we have this anonymized. We actually categorize age, we categorize city birth, we categorize zip code. We cannot affect disease, we cannot alter it, we cannot anonymize it, because if we do so, we'll lose the important aspect of privatizing or privacy, that we won't be able to use it. So there's no point selling this data or no point using it. System flow, this is the last thing which I'm responsible to complete. So what we'll do is, what we did is, this is the core process which constitutes the very heart of data flow algorithm. We'll start with computing a frequency count of the table with respect to the attributes in the QID set. Now QID set is actually the quasi identifiers. We'll generalize table using the attribute having the most number of distinct values, and if it's not like that, then we'll reiterate in a loop. We'll also check if k anonymity is satisfied or not. Is it up to the mark we wanted to have? If it's greater than or equals to k, then yes, we'll return the anonymized table. If not, we'll try table suppression. We'll try to have those frequencies less than the like maximum threshold which we wanted, which we have denoted as sub threshold. If it's yes, then we'll suppress the table and directly return the anonymized table. But if it's not, we'll generalize it again, using the attribute having the most number of distinct values, and then we'll reiterate the loop, check for if it's finished. So this is Siddhant Tiwari signing off, and I guess Laksh will continue here. Thank you.
Gupta, and I'm going to describe the core process of data flow algorithm. As you can see on the screen, we start by computing the frequency count of the table with respect to attributes in the Q identity set, which basically means that we count the number of unique values that occur in a particular attribute. Then we check that if k anonymity is satisfied by these attributes. That means if there are at least k indistinguishable attributes. If it is satisfied, then we just return the anonymized table because it's already anonymized. If it's not, then we check if the table is ready for suppression. That is, if the frequencies that we calculated earlier are less than the supported threshold. If they are, then we can just suppress the tuples with frequencies that are less than the supported threshold and return the anonymized table. If the table is not ready for suppression, that is frequencies are greater than the supported threshold, then we generalize the table using attribute having the most number of distinct values. That means we try as much as we can to generalize the table and anonymize so that k anonymity can be satisfied. Okay, this is the list of all the software and hardware that we required. As we have mostly used Python for our algorithm, and we've used Jupyter Notebook as the development environment. Result analysis. So as you can see on the screen, we have taken two screenshots. One is before we have done our anonymization and one after. And as you can see, the anonymized or raw data set consists of all the quasi-identifiers which can lead to user identification. And the data flow algorithm that we've used help us reduce these quasi-identifiers and will make us able to publish this data for further use without the chance of it being traced back to an individual. These are the references that we use. Datafly, the system for providing anonymity in medical data by Latanya Sweeney. This is the core research. This is our base research paper that we've used, and other resources like the second one, online resource, which is our data set that we've anonymized. Thank you.